Hello, I'm MC Toon, and this is my analysis of the submission to the Sextant Challenge, or the Celestial Navigation Challenge, done by Wisekoff. So, to be clear, to start off right now, the challenge has a provision for independent judging. It's spelled out in the challenge. If it says, if you disagree with my analysis, with my decision, then you can choose to go for the independent judging panel's process. There is an independent judging panel process where it's completely taken out of my hands. What happens is both of us choose one judge, and there's the criteria spelled out for what the credentials are for that judge. And that will definitely be on the panel so long as they meet the criteria. And then we each put forth another judge, and then we create a Reddit thread. And then we have people vote on that Reddit thread for the remaining one judge spot. So I cannot fill arbitrarily with my own people the judging panel, and neither can the other person. It goes to a vote outside of our control. We, of course, each would get a vote, but it will go to other people to make the decision. So then that makes a judging panel of 3 people. I have specifically asked Wisekoff for the names of the 2 people that he would like to have judging, should he disagree with my decision. At this point, he has not sent the names of the people that he would like to choose to be on the independent judging panel. This tells me that, as of yet, he agrees with my decision. So anybody saying that I owe him money, he has chosen to agree with my decision so far. If you think that's incorrect, you definitely should go to him and say, Wisekoff, go ahead and select your judges and send, and let's get that panel going. I look forward to it. With that, let me explain what this is about. I wanted to put that out there right at the beginning so that people knew, no matter how much of the video they watched, so they knew exactly what I'm talking about and how I intend to be honest and open about this process. He has not yet sent me that. So at this point, I must conclude that he agrees with it so far. So here is the challenge right here. It's on my website, mctoon.net. It's right at the top. You can click on it. Here it is. This is version 2. There are 2 versions. You may choose to do either one. The differences are slight, and I'll cover the differences. Typically, flat earthers do not read the challenges. I have yet to actually have a flat earther attempt a challenge after having read the challenge. I don't know why they don't. It's there. It does not cost them anything to read it. The point is, though, here is the challenge. Here's how it's to be paid out. I showed that I have the money in escrow. The specific challenge right here, you can download the official text file. Here is the SHA-256 hash, which I announced in a video, and it's got that on the screen. So months later, if I changed the challenge, you would know about it. Here's how I generated the SHA hash. Or you can do it right on command line, like I did, or you can do it on a web page. I verified that both match, actually. And right here, this begins what's inside the official challenge document. But to be clear, the official challenge document is the only authoritative source. This is just a replication of it. That's not it. It begins here. This right here is the first line of the challenge. These are the observation angles that are referenced in the challenge. In essence, and I'm not going to read all of it, but in essence, flat earthers are to detail the process of doing celestial navigation using only flat Earth. The challenge is not to get the actual position for one set of measurements. It's to give the process so that that process can be done to all measurements. Right? So you detail the process. Of course, you probably want to make sure it works for the one that I have provided, which is right here. Right? You give me that. If you have it, if it's correct and you did do it right and match the the challenge, then within, I think, 48 hours of you sending me the process to do it, I will send you another set of observations. And I have a few of these in reserve, several different observations taken with real sextants by people that are certified to use sextants, not just right. Not that it would matter. I would be okay with an app, somebody that has a high amount of aptitude using a sextant. And of course, all of these things can be confirmed by just applying them. Anyway, I'll send you the second set. And then if your process works, you cannot change the process, works for the second set of measurements, then you did it. You successfully did it. But because this is a flat Earth challenge, you can only use flat Earth. Now, why would a flat earther want to use the globe to prove flat Earth? That would be quite ridiculous. The first version of this challenge said that you may not use a nautical almanac star position, star charts that were based on a celestial sphere. And Nathan Oakley had a little hissy fit. Yeah, so Nathan Oakley and his troop of clowns had a little cry session where they whined and cried, and they're like, oh, they could not get over themselves with how sad they were that I said that they could not use a sphere to do celestial navigation on flat Earth. How could it work? I don't know, but they certainly wanted to. So I made that concession. I said, you know what, Oakley? You go right ahead. You can use the position of the stars in the celestial sphere, which is a concentric sphere around the sphere Earth. You go right ahead. You need to provide the mapping. How does that map to, to the flat Earth positions? You need to provide that, but you go right ahead and use them. This is an important distinction for this particular video. We'll get to that in a little bit. The other change that I made in this one was Bev Try-Thinking, who never does Try-Thinking. He complained because I used the words flat Earth geometry, and he did not know what that meant. Now, Bev Try-Thinking is a flat earther that is too ashamed to admit that the Earth is flat and says, oh, there's mountains and hills and valleys. Yes, Bev, we know. Nobody actually thinks that when we say flat Earth, that we think that there's no topography. We know that you think in your head, Bev, that this is the map of the Earth. We know, Bev, that every night you cry yourself to sleep hugging your Gleason map plushy pillow. Right? Available on my Teespring store. Not kidding. All right. So I added a definition. Flat earther, a person who posits the flat Earth idea as posited above, right here. This includes these ideas. The Earth is an infinite plane. All horizontals are parallel. That's Bev's position. The surface of undisturbed water is flat, and other ideas that have similar implications. That's what a flat earther is. Bev is a flat earther. Anyway. So those are the two changes. You can use either one you want, but I'm certain that Wisekoff would want to use the second version here. That's because I do allow, ironically, I do allow you to use star maps, celestial positions of the stars, as defined in the heliocentric model. Yep. And I did that because I know that it doesn't help. It doesn't help. But it comes into play. It does. So anyway, so this is important. Using only mathematics applied presuming flat Earth, as defined above. Mathematics presumed flat Earth. Use the elevation angles of three separate stars to determine the observer's position on the Earth twice. Two different observations, two different times. In the event, it identifies within the accepted parameters, which Wisekoff did not. I'll get to that. A second set of elevation angles will be published, and the submitter shall use the exact same celestial navigation method to determine the location of the second observer. All right. Now I want to show this here submission method. Any combination of the following are acceptable, right? A YouTube video, web page, email. Submission communication method. This is important. A notification of submission must be sent via email. Now, Wisekoff did not do this. I noticed his videos and I sent him an email. So his submissions never actually sent me an email. Now, after I did that, then yes, fine. We were in email communication. But he didn't even read this part of it because he just put a video out and did not send me an email. Wisekoff, read the challenge. So do you have positive evidence or not? No other flat earther does. Do I have positive evidence? Are you talking to Wisekoff? Is he in the chat? He was poking around earlier. Anyway, all right. Talks about the prize. Yep, it's in escrow. It's 0.4 Bitcoin if the value of Bitcoin is less at the time it's detailed in here. Right there. There it is. MC Tune's primary judge. Should an entry be submitted but rejected by the judge, which it has, and this rejection is not accepted by the submitter, he has accepted, so far, my rejection. A panel of 3 experts shall be named in accordance with the legit challenge framework specification 0.9b, section 5.1, and I give the link to it right there. Each judge must be qualified in one of the following ways: a professional ship navigator with at least 5 years navigation experience and currently employed as a ship navigator, or a professional celestial navigation educator with at least 5 years of educational experience and currently teaching celestial navigation at least once a year. There it is. And they have to provide verification of their qualifications. This is a celestial navigation challenge. Any judges must be sufficiently qualified in the topic. So, can Wisekoff even read? Or does he rely on text to speech? I don't know. Expiration. There's no expiration date, but at my discretion, I can withdraw it. I need 30 days notice, so I can't just take it down. You see, flat earthers, this is how to do a challenge. The money is out of my control. The judging is out of my control, should they not accept my challenge. And, as we shall see, the clear acceptance criteria is stated. Anybody can look at it and see that is an objective acceptance criteria, right? And I cannot change them because I've put it out here, and there's a SHA hash, so you can download it. There it is. All right, a couple different notes. The important thing is, no, I think it's in the notes where we need to go. Then I'll get to his actual submissions. He has 5 actual submissions. Let's see. Yep. First set of elevation angles, second set, each set. These are all on my website. You can read it at your leisure. I'm not going to go into detail of everything here. All right. Nope. I guess it's up farther up. While there are no active submissions in progress, the published first set of elevation angles to 3 separate stars can change without notice. All prior sets will remain on the website with dates when they were active. Any submission using a set of elevation angles to 3 separate stars can use a previous set for no more than 3 days after it's deprecated. I cannot just change it and take it out from under you. If you're working on something, you have a 3-day notice to work on it. All right, this is I got to go up here to get to the really important part. The challenge acceptance. So here is a clear acceptance criteria. The position of the observer must be determined. The position of the observer. Take note of that, people. You're going to piss yourself laughing later. The position of the observer must be determined within 25 statute miles for both sets of elevation angles to 3 separate stars. One observer. The location can be latitude, longitude, street address, or relative distance and bearing to a landmark. I tried to be flexible, right? The exact method used to determine must be included in the submission. All details used must be provided so a third party can perform the same steps to get the position. This method will be tested independently of the submitter's answer to verify the same answer is obtained. This is important. If a different answer is obtained, the submission will be invalidated. If the method is not sufficiently described to perform calculations, the submission will be invalidated. The method must only use mathematics and data that presumes flat Earth. As defined above, any method or information presuming the Earth to be a globe or derived from a globe invalidates the submission. This includes maps, site reduction tables, dip charts, refraction charts, and calculations of distance over the surface of the Earth, like the Haversine formula, the Vicente formula, 60 nautical miles per degree. Those are all derived from the globe. If you're going to use them, you need to provide your own derivation. Right? And then one exemption is allowed, a difference from version 1, even though the star chart's placed in a concentric sphere around the spherical Earth, existing star charts published in nautical almanacs may be used for the challenge. The specific method used to transform the spherical data to a flat Earth, as defined above, flat Earth plane, must be described in detail, sufficient to be applied independently during the validation of the submission. This is important. Keep these things in mind. The method must include derivations or citations to the derivations of any numerical constants used or in any formulas or calculations. There it is. Okay, so here we have his first submission. Like I said, he did 5 of them. 5 of them. This is the first one. All right, I'm going to play a little bit here. I'm starting at 8 minutes in. I can't play all of them. It's just too long.
Incarnated god of Ra and Thoth, like some of the other flat earthers. So we're just going to go ahead and impose a couple things. We could go world map. This is still a 2-dimensional perspective. There's no sphericity implied here at all, but I prefer...
Of course there is. That is a map, which is a projection from the globe. Clearly stated in the rules, anything derived from the globe, any maps that are projected from the globe are invalidated immediately. If you use the Mercator projection or the equirectangular projection, which this kind of looks like, that invalidates it. If you use the azimuthal equidistant projection, that invalidates it. Any map projection from the globe immediately invalidates it. You must use a map. If you use a map, it must be a flat Earth map, and it cannot be from the globe. This map, for example, this map says projection on it. Right there. It says projection in the patent application. This is an azimuthal equidistant projection from the globe. This is a globe map. If you're going to use a map, you must use a map that's not from the globe. Why, if you think the Earth is flat, why would you want to use the globe? It does not make sense. You have acknowledged that the Earth is a globe if you use a globe in your navigation. It's that simple.
For the polar globe. And this is starting to look a lot more like a flat Earth map, doesn't it? Isn't that neat and nifty? Well, anyways.
Azimuthal equidistant projection.
So here's our location, which is just kind of north of... and if I had the time, I wish you... Did you put the time in there?
I did. It's right there. It's on
so
screen.
There's no time. So this...
It's right. It's right there on screen. Right there. Just to the left of your cursor is the time.
May vary slightly throughout the day, but...
Of course it varies. In 24 hours, it goes all the way around because the Earth is rotating. It varies a little bit. It varies a lot. But the time's right there on the map. Just right there.
We're basically just above Australia. And the locations we're looking for are just slightly northeast of the start location. Whatever this is, like this is Australia here. Whatever is just above it's like right above that, just northeast of it. And then we've got, that's the Regulus.
He gave the position of Regulus at an unknown time.
And then we've got Dubhe, which is basically right on the tip of that landmass there. And then we've got Arcturus, which is right on this like little island cluster here. So there's, again, just slightly northeast from that geocentric perspective that we've designated.
That's not a geocentric perspective. Typically, geocentric means when people say geocentric, it's still a globe.
Just slightly northeast or to the right, 2 o'clock or so, you could probably see it right from the starting point location. For this Dubhe perspective, you'll need to traverse up to this landmass here, and we should be able to know that this inlet is taking place here, especially if we're sailing along.
He just sailed through the landmass of Asia, by the way. He doesn't even know that the route that he used with his cursor was over land, not over water.
These seas here, we should know that this is the case, and it's right in this little landmass. There's a slight inlet right there as well, right? There's a nice big inlet right here that we can vary this off of.
That's a peninsula, not an inlet.
These are landmarks that we could use. And Arcturus, as I said, just southeast. Southeast of the
of what?
The small islands here. So
yeah, and now he got that as water. What he did is
that's sufficient. Again, there's no a star map that I'm using. This is just calculation.
He did use a star map.
My computer's calculating it for me, but this isn't any spherical nature. If I want it to be, we can impose that sphere. All right, so we can go globe, and you'll see it's the same thing. Just north of Australia, northeast. There it is. This is the difference between going from spherical to a two-dimensional flat plane. It's all the same shit, man.
Oh my gosh.
Because it was originally created with the sextant in mind, looking at the stars.
All right. So his first submission, he did not know the time, even though it was on the screen. And what he did is he gave the positions of 3 stars using a method he didn't have any clue about understanding. He gave the positions of the stars, not the position of the one position of the observer. Seriously, how dumb. All right, here is his second submission. He promptly deleted that first one. I got a copy. Here's the second one.
What's going on? So here is my my attempt at a flat Earth projection of not this, but this is just something where I got theorizing that the pole's rotating this way. As we have data that they have. It was back here.
Oh my gosh.
I don't know how many years ago or whatever, and I'm theorizing that they're going to continue. They're not going to be going around the globe. They're going to be continuing this trajectory, but just something I like to use to visualize things, especially a really good way to drive home the sunrises and sunsets.
Yeah, it doesn't work.
What I want to go through here is, and I just deleted the video, realizing I've explained it all wrong. These star charts are very complex, just interpreting them, but the data itself is completely in your control, at least with this one. I know I have other ones like Ganzilla and timing solution. There's a bunch of them where you don't have that control. This astrolog though, 6.5, and like I said, you may need to add additional files that they have on their website that you just expands the program, but for this purpose you should be good, just with kind of the stock version of astrolog, and we are imposing everything, all the calculations. So right off the bat, one thing that's wrong with the challenge itself, to be done from, and maybe it's not on a globe, maybe it works fine on a globe, but to be done from a flat Earth perspective, you need the time of day that you're doing it, and you
Yeah, you do need the time of day.
didn't specify what time of day, but so it's going to vary. But nevertheless, the trajectories are
Just for reference, Wisekoff. It's right here. Here's the time of day. Right there, Wisekoff. Right there. It was on your screen earlier, Wisekoff. Dummy.
still going to be there. So let me just set it up for the day that you were saying. So I just removed all the stars, or all the wandering stars or planetary bodies. And now I'm going with the point in time. Now the longitude, latitude is only relevant when you view it in a spherical nature, three-dimensional geometry. This will vary it as well slightly, the time zone. So like there's really not enough information in the
there was
in the challenge to complete it from this perspective, which is hard enough to do as it is. But we'll go with UTC. It's not going to change things too much from what I've seen, but it's going to have those 4-hour shifts or so. So it could be,
if you read this, you could have done it
dramatically off. I don't know. I haven't compared both datas, from a spherical perspective and from this perspective, but the time of day is relevant. Now, in the previous video I just made, it was 9:15 p.m. So we'll stick with that. The trajectories should still be the same. And what's relevant is, again, you can see we're not in that astrological point. It's just showing something else. So we'll go.
Yeah, this software is using is astrology software, by the way.
And it's been so long since I've even, I forget, what is this, Taurus? It's been so long since I've even looked at this, but let's have a look at the calculations, which is the only thing that's relevant here. This is a 2-dimensional flat plane, and there's 0 things imposed to it, right? The only things that are imposed on it right now is the Swiss ephemeris.
The 2-dimensional flat plane is a projection imposed on it. But he gets here, this is interesting. He gets into this little thing here. This is important.
Right. The only things that are imposed on it right now is the Swiss ephemeris calculation method. I'm going to switch that to what the military uses from a heliocentric perspective, by the way, but which is all wrong. When you do any sort of testing of data and correlation, is just not there from a heliocentric perspective, but it is most certainly there from this geocentric perspective, which I'll show you here. The calc ephemeris, right? So that alone is the mathematical.
All right. So he's using the Placalc ephemeris. The Placalc ephemeris is an API where they actually use the Swiss ephemeris, and he gets to using the Swiss ephemeris later. But just so you know what it is.
The calculation of it, and when I select this here, computing the solar system as a very center instead of the sun creates the center of the universe as Earth. And
no, he doesn't know what barycenter means. Oh dear, the ignorance. Barycenter would be the point around which 2 objects orbit. So the Earth and the sun both orbit. To be super technical, the Earth doesn't orbit the sun. The Earth orbits the barycenter of the Earth-Sun system. And the barycenter of the Earth-Sun system is partway between the Earth and the sun. It's so close to the actual center of the sun that it's inside the sun. Similarly, the moon and also the sun orbits the barycenter of the Earth-Sun barycenter system. Anyway, similarly, the Earth orbits the moon. The Earth and moon orbit the barycenter of that system, right? Which also is inside the Earth. Also causes the tides because the Earth has a small orbit around the barycenter of the Earth-moon system. Tides. And when they say gravity causes the tides, they're one step removed from gravity causing the tides. It's a little bit of a simplification. Anyway, that's what barycenter means. It doesn't mean flat Earth. It's just changing the coordinate system to be origined at the barycenter of the solar system instead of the sun, the center of the sun. That's all it is. It's still a 3-dimensional system. So, all right, let's keep going. A little more here on this one.
And it flips where the Earth and sun are, and I'll just drive that point home a little more I'll go ahead and put on the Earth. You can see it's, what did I do? Shit. Hold on. I'll put on this program's ass backwards. You can see there's the Earth. There's the Earth from the heliocentric kind of calculator, just from this calculation. It's still showing as it's geocentric, but this calculation method is just all wrong. It is correct, though, when you impose it and force that geocentrism. So that's what I'm going to do. You can see by adding this to compute it as the barycenter, it's kind of just 2 calculations going on here. But calc, barycenter, it flips them, and it's now...
The barycenter doesn't change the actual model. It changes the coordinate system.
Here's the Earth, which is accurate with the astrological perspective for that day. So we don't need the sun. I'll get rid of that. And it's just this. And now the one thing that I failed to mention, or even failed to think about in the first video, is this is the center. This is the point of observation. So this is where all the geometry gets laid from that you're asking for. And that geometry is laid, in this case, in my example here, through the Placalc calculation with the barycenter computed. So this is going to be a center, as opposed to if I didn't flip it and force geocentrism, it would be all wrong and it would be up here. And they would just be heading in the wrong direction. This is going to give you the right direction, or should, in theory, in my presentation here, which is a very limited experience with this. It just all makes sense to me from what I've seen. So, just based off of an astrological perspective, very hippy-dippy stuff going on here. But so now we're going to pop on the stars. And again, the point in time is so relevant. This varies throughout the day. But, there may even be a way to read this here, but this is your angles right here to the center. I don't like that. I don't know how to read this at all. But and you know, there's no land masses for us to give reference points to or anything, right? So switching on,
it's astrology stuff.
a polar globe. Now, the term globe is misleading because it's not in, you know, this here, and you chart it as a sphere. There's geometry going on there, or you can chart it as just the globe. This is spherical, three-dimensional points going on. Still the same thing, though, and the same locations, where this is going to be our start point, and these are what you're looking for. And you can see there's that center point that it's running from, as opposed to this, which is maybe what I think you spherical guys are observing, getting wrong. I don't know, but let's go ahead and put it back.
To be clear, this is also a projection, because his screen and your screen is not three-dimensional. So it's also a projection from a globe. I got to remind you, although you are seeing me in 2 dimensions on your screen is flat. I am not in reality flat. Just so you know, you are seeing a projection of me on your screen. So when flat earthers say, well, all maps are flat, that doesn't actually mean anything. That just really shows their lack of intelligence. The source of the projection is a globe. If the Earth were flat, then the source of the map would be flat. And there would be no distortions on a flat map of a flat surface. There are distortions of a flat map, of a spherical map on a flat surface. They don't get it. It's that dumb. They're that dumb. All right.
Back to that 2-dimensional perspective. Looks a lot like a flat Earth map, doesn't it? This isn't, even though it's a globe, again, in my opinion, it's just labeled incorrectly. It's a
It's just labeled incorrectly, he says. No, it's a projection from the globe.
Dimensional plane that we're looking at, and this is, you can see that distortion, right? You can see how this is all like squished out from the normal globe perspective, right? On the globe,
the normal
it's just
globe
much more what we're used to, how it's all laid out. This is still the exact same information, and here's the polar point, is the center point. This is kind of the location of observation, and this gives you the angles as to where it's at. There's Australia. You can see the angles from that center.
Why does Australia look like a hot dog instead of a hamburger? Australians in the chat, are you offended that he thinks that Australia looks like a hot dog when it's a beautiful hamburger?
Point. Here's reg. So I don't have any degrees on there for you. I would need to switch it to the polar globe and spherical nature. But this is the location, and this is what you said in the challenge, is rough landmarks. Just north of Australia, whatever this fuck off island is, just north of that.
Whatever that is. Whatever that is.
I forget the name of them. I've closed it. Then we've got the Dubai or Dubhi, located just on this landmass that's here. And for reference points of landmarks, there's a nice little inlet here. This should be very, if you're traveling these seas anywhere, traversing the seas, you should be able to see this landmass, this little inlet, and that's your point, right, where the star will be located. And this is all coming from a center point of the north node. This is the entire crux of
the flat Earth
argument. Is that it's all from the center and comes outwards. This is what you're seeing right here. Whether this is precise landmasses, I don't know. Even to me, it looks.
All right. For reference, Wisekoff, that's Papua New Guinea.
Pretty fishy, right? And I don't know, is this North America? I don't even know what's what here. But I would have to look at it from a globe.
All right. Oh my gosh.
Pretty fishy, right? And I don't know, is this North America? I don't even.
No, that was the southern tip of South America. That's how dumb he is.
Know what's what here, but I would have to look at it from a globe because it's all that we've been indoctrinated is. But nevertheless, the Arcturus is just this little island cluster. It's literally just a little southeast, if you will, of that island cluster right there.
Arcturus. That's called Hawaii.
There. So this is it.
So he's trying to send the submission as, seriously, here are the positions of 3 stars. This one is just north of the island cluster that I don't know what it is, Hawaii. Not the position of the observer. Didn't figure out the time that was on the screen.
And if you want,
all right, that's number 2. My gosh, how stupid. All right, here's the next one.
Okay, so what is going on, people? But so a couple things with this challenge. Maybe it is possible to do from a spherical, with spherical geometry and math and perspective of it being a sphere, but from a 2-dimensional plane, we actually need some more data here. I would.
Yes, this is Wisekoff talking, and no, you don't need any more data. The data you're seeing right there is enough for anybody that has a little bit of experience in celestial navigation to get the position.
We need to know the point in time of the day.
It's literally on the
taking
screen.
this from, and which time zone is it in?
It's literally on the screen.
I know you're going to think that might sound redundant, like you need to tell us the location of it, but based on the stars will be
right there. It's right
and this is maybe a perspective thing that
right
the globe people aren't understanding, is that the stars will appear to be in different
It's literally under your cursor. You're going around it there, Wisekoff.
places depending on where you're situated
Absolute
on the planet. That's kind of the whole point of the argument, and it's a major difference in the two perspectives.
Embarrassingly stupid.
So you would need to, in order to present this with a 10K challenge, we can just go and do it from your spherical side, but that's nonsense. You're asking for a flat fixed plane, and to do that we would need to know the location, because that's our whole argument.
So wait,
is
you need
where
to know the
you're
location to
located
get the
on
location?
the planet will dictate what stars you see and things. It's not just the night sky is again, I think that's a huge point that you guys are missing with our entire model, is perspective and how your eyes work.
Do tell, because I spent 2 hours trying to get Flatzoid to explain how perspective works, and he never had the answer once.
In the first video I made, and I'll just use those same settings for this demonstration.
Let me speed up this talk.
Before I do that, I just want to really drive home the point that there's nothing spherical going on here. And the definition of globe, because that is an option that I choose in the software here. In my opinion, this is labeled wrong. It should say polar map, not polar globe. But nevertheless, the globe is fine because it means a spherical or a rounded object. And that's what we're working with here, is a rounded object on a 2D plane. There's no three-dimensional...
Just for reference, all the calculations in there are done in 3 dimensions as a 3-dimensional sphere.
Geometry happening here. It's strictly 2D, strictly a flat plane perspective.
How stupid can you be?
What we're doing is, let me just go ahead and grab the right date.
Wisekoff.
And that's the most information you've given us, is the right date. We need to know the time. And, the general time zone. And with the previous video, again, that's the whole important part that you guys are missing, is where on the planet are you located is going to dictate how you see the stars. That's literally a major difference of the two models, my friend.
Yeah, you deleted these.
I'm trying to help you out. I'm trying to play along within the rules of your game. It's just not a possible thing to do. You're asking for something to be presented from a spherical, the heliocentric model's perspective, and that's not what we are, right? That's kind of nonsense to even preface that as a challenge. But playing your little game there, what I think the challenge should really kind of be revised to, if possible, is, hey, here's the locations and the time, the exact point in time of the day, very important. And what angles are they coming from? And if perhaps maybe you don't want to...
Oh, well, we can do that too on the globe. We can definitely say, here's an observer, and here's a couple stars. Tell us the angles for that specific time of day to those stars. We can do that. In fact, Thad has done exactly that. I'm not going to get into that now, but we do that all the time.
To now use software like what I'm using here, it is a bit of a cheat because it does all the math for me. It is still math, though. Ultimately, if I wanted to, I could learn the execution of these calculus,
You're not smart
whatever form of math it is that we're doing. I could learn those and apply it in the exact same form on a 2-dimensional scale.
Not even close.
It's just the computer does it for me. It's like cheating in school back in the day where I would use a calculator. When the teacher tells you don't use a calculator, well, I'm using a calculator, sorry. It doesn't change the fact that the operation of it is still legitimately, from a geocentric perspective, flat fixed plane, which is the center, and we're viewing outwards. So in order to get that, I'm just going to, same thing I did in the last video, I'll put the stars on. You're asking for those 3 stars, and I'll get rid of the planetary bodies, or wandering stars, as we so politely call them. And then we need the calculation method. And so this is the whole thing of it. And most people trying to present you a geocentric perspective will probably give you the wrong points of view, regardless of you giving them the correct time of day. I'm quite confident in my calculation method, though, that if you simply just apply calculations in the Berry Center, you're going to get the right perspective. But as you can see, and I think about...
What's Berry Center? Wisekoff? You don't even know.
This not set to day. So as you can see, though, when I change it to navigate throughout, it changes where it's going to be perspected at any point in time. And this varies by the hour. It'll change dramatically when you scale it out with the planet.
Yeah.
So again, with the previous video, the time of day and perspective is everything.
There you go. So he's whining. He needs the time of day. Yep, it's there. Yep, it's there. All right. Here's the one he called number 3, which is actually the 4th.
What is going on? All right, so I really do appreciate this this challenge by McToon, as it really does drive home our complete differences in perspective. And this is just an argument that not enough scientific people will even consider, I'm sure. But I did download it. If you watched my first two videos, I was using Astrolog 6.5. There's been quite a few iterations since, but I'm using the latest version, 7.5 now. Which sadly they've changed the calculation methods. I really wish they left Plecalc in there, but
Plecalc was just an old API that was deprecated a long time ago. And so they took it out because it was not needed anymore. It's the Swiss ephemeris is what Plecalc was anyway. And so he uses the Swiss ephemeris, and he gets into that in a little bit here.
You can basically get the same results. This isn't relevant, but I just went with Galactic Center. It's just for the Zodiac. It's not relevant with this particular two-dimensional flat polar map. And what is relevant, though, is computing the solar system barycenter. So it's the center of the universe. And this is what's so important, in my opinion, about this entire argument.
For reference, the barycenter is 93 million miles away from that particular thing that you're looking at on the screen there, by the way, in the model that you're using.
Is things will vary depending on where you're located on the Earth. And Eric Dubé's made a great video of it where, I mean, you can basically just quadrant quarter off the Earth, and you're going to be seeing things differently depending on where you're located, your point of perspective. So what we've got here, and both set to the UTC time zone, not relevant from here, but this is UTC, on the day and night world map, which just shows you where it's nighttime. So at this point in time, at 12:15 a.m. on November 15th of 2018, this is what's basically dark, right? So looking at that from here, we've got all of, we're basically looking at it like this, right? So this is Africa, and this is, and just having these two maps side by side, you can really see that distortion. But,
He admits it's distortion. A flat map of a flat surface does not have distortion. Clearly, I mean, just admitting that right there, it invalidates his submission because, well, he didn't read it. You cannot use a map that's from the globe. And PJ CNET was in the chat whining about that. And somebody said that Brian Leake was complaining about that. What, flat earthers, why do you want to use the globe for flat earth? Use your own stuff. We got the globe. I know you're jealous. I got it. You got nothing. You just lose all the time. But come on, try.
Just gonna turn this music down a little bit. But what we have.
Oh yeah, that map. You can walk from Australia to Papua New Guinea.
Is Africa here, completely at nighttime. And these, sorry, just to clarify, these are the polar lines and the trajectories of the star, and it's viewable on two different places on the planet at the same time. Will be right here and right here. It's never nighttime at these opposite places, and that's that whole yin yang thing, right?
It's never nighttime at these opposite places.
But we've got Africa covered, but so some of Brazil is just slightly getting dark here. So we may be able to see Dubhe here, just south of it, but again, it's not even really dark there, so probably not. But Arcturus, as you can see, is just.
So he's still getting the positions of the stars, not the position of the observer.
Here. So you should be able to most certainly see it.
In his fourth entry.
In the, just east, or just east of, from our standard indoctrinated perspective of direction, just east of Arcturus. Paradoxically enough, it is also here, right? So let's go look at this, which right above Australia, it's daylight, so you're not seeing it, but Arcturus is right over here. So that's a paradox that you guys need to wrap your head around about perspective, just where you're located on the planet.
No, that's, I don't know. I have no clue what the software is doing. I really don't. It doesn't matter much. But I think that this is showing the GP, but he doesn't have the time yet. So I didn't even check any of this, right? Because it's a globe-based map, and all he's done so far is put the stars on it.
And what are you going to see? But let's move ahead. I'm just going to skip ahead 3 hours. And we've got most of Americas covered. So what do we have here is Arcturus is basically right here. As you can see landmarks very clearly here on both maps. Arcturus is literally directly overhead at 3:14 UTC time, directly overhead here in Africa, or Brazil, excuse me. And just quite literally, and wherever you're, I'm in.
So at this point, I emailed him. At this point, and I said, like, you're not even in the ballpark. Read the challenge. I just said read the challenge in the email. He's like, what do you mean? I emailed back. I said, you need to get the observer's position. He's like, I don't know how to do that. I said, I know you don't know how to do that. I said, well, I can show you how it's done on the globe. And I told him, I actually, through a couple emails, I told him how it's done on the globe, right? Got this book, I can do it myself. I said, you need to get the observer's position. To do that, you get the angle that they used. Then that helps you to, then you know, when you know the GP of the star, and you know the angle you are to the star, then you know how far away you are from the star on the globe. And then you can draw a circle that's equidistant from the center of the GP of the star. That's at that distance. So you know the distance to the star because of your angle, right? If you're at a certain angle, it's 60 nautical miles per degree. You just multiply them, and that's how far you are from the star. Draw a circle on the globe at that distance, and you know that you're on that circle somewhere. That's it. It's a circle of equal altitude. And the altitude, the word altitude is talking about the angular altitude of the star. So everybody on that circle measures that star to be the same angular altitude. All this is in an email. I sent it to him. I was helping. I was teaching him for free. For free, I'm teaching him how to do celestial navigation on the globe. And I said, well, I don't know how the flat earthers might do it. 60 nautical miles per degree works on the globe. It's because of the curving surface. On the flat earth, it's going to be an arctangent relationship. Of course, he doesn't have a clue what arctangent means. He doesn't know trigonometry at all. Now, I don't know about in Canada, but in the United States, it's covered in 11th grade. So I know people don't use it often. They're going to forget it, but it was covered. You have a responsibility to at least have some idea of its existence, right? Anyway, I said, and then you plot out, and then so what I did, and he's trying to figure it out. I'm like, all right, well, I will teach you how to do it on the globe, and I did that. I was really nice to him, for free. I mean, I do every week I come in here. I teach people for free how to do things. So, all right. Well, I will. That's not. There we go. So I'm prepping something here for you all to see. There it is. Okay. So here now we get to the one after I taught him how to do celestial navigation. I sent him a bunch of things. And here is his entry applying the things that I taught him.
What is going on, sheeple? This one is just a little version 2. It's a little follow-up for the haters that can't accept that L.
Oh wait, sorry. That was number 6. This is number 5.
Is going on, people? All right, so this is pretty deep, and I really wasn't expecting this at all, but McToon.
It's important to see on the screen there. Convert coordinates to spherical to Cartesian. So I told him that there's coordinate transforms. Now he is not intelligent enough to understand what a coordinate transform is. So before we get into this, I'm going to show what a coordinate transform is. I don't know why, but when I was in Algebra 2, I loved polar coordinates. I really enjoyed the section on polar coordinates. So I will show you here by way of analogy using planar coordinate systems. I will show you how it works. Just in this as an example, right? There is a circle. Does anybody know the formula for a circle in Cartesian coordinates? First one to get it in the chat is a big wiener. I did love Algebra 2. And so when it was time for polar coordinates, I actually wrote some software on my computer. This is how nerdy I am. I wrote a software to plot out, given a formula, to plot out the polar coordinates. So there you go. Wiggles is the big wiener. So I wrote, so here on the computer, the origin, which is up here, right? That's 0, 0. And it goes up this way, and it goes up this way. Higher numbers this way. But to transfer, I had to first transform that to the center of the screen so that the origin was in the middle and that we had the 4 proper coordinates of our quadrants of Cartesian coordinate system. Then I had to do all the transforms to go from polar coordinates into that particular already translated coordinate system and then plot everything out. I loved it. I really enjoy this. And I turned in my homework. I printed out the plots because that was the assignment. Draw out this formula. I did that. And the teacher said, nuh-uh, you did not show your work. So I printed out the program and I handed it to him the next day. He said, nuh-uh, you didn't show your work. I don't know what this is. He gave me 0 points on it. I did not do my work. I knew I didn't have to because I was going to get an A in the class anyway. And I learned, I'm pretty sure I learned polar coordinates better than anybody else in that class, even though I got 0. Anyway, so the formula is, and I'm just going to do a unit circle. There it is, r squared. Did I get beat up in school? No, facty. Wow, where'd it go? Yeah, there it is. So I did not, because I hung out with the same kids. Actually, I was a wrestler, so it wasn't a problem for me either. All right, so that's the formula right there in Cartesian coordinates. But now it's a little bit easier in polar coordinates, and so you might wonder, well, why use polar coordinates? Why do transforms? For just a unit circle of 1, there it is. There's the formula in polar coordinates. R equals 1. Well, that's a lot easier. So depending on what you're doing, it could be easier in different coordinate systems. But here's the thing for you, Wisekoff. Whether we do it in Cartesian coordinate systems, and this is the formula we use, or we do it in polar coordinate systems and use this formula, does that change this shape? It does not. That's still a circle, right? This is the formula for a circle, and this is the formula for a circle. You can see that one's easier, so for certain uses, that might be the way to go. Similarly, for spherical coordinate systems, you have r squared equals x squared plus y squared plus z squared, and r equals 1 in spherical coordinate system, and to be a sphere instead of a circle. The coordinate system you choose and the transformations you choose does not change the shape of the thing underneath. So changing the coordinate system, Wisekoff, does nothing. You need to actually model based on the shape of the thing inside the coordinate system. Okay? All right, so here we are to his submission that he thinks is the winning one.
Has a challenge, and if you were paying attention, I've kind of addressed this challenge already, but I was doing it with the wrong calculations, and just had the wrong locations. And news to me as well is, the best part of this all is that Mick himself has actually walked me through this entire ordeal. So, and I mean, I'll just pop on the screen here real quick. Nailed it, awesome. And then it was just me saying, I literally just smashed buttons, taking the flat Earth map and the Swiss ephemeris formulas, which we'll get to here, from a geocentric perspective. And it really truly is the first time that I've had confidence that what I'm creating is astronomically correct. Anytime I've dabbled with the astronomy, it was basically an astrology-based experience where I'm just trying to find correlation, and some astronomy, I'm trying to find aspect changes, retrograde periods, and things like that, which show some sort of market correlation with the financial markets. So yeah, and I'm like, yeah, so I kind of completed your challenge. And then he's like, using the Swiss ephemeris or any of the other ones uses the globe. It doesn't though, my guy.
Yes, it actually does. And he brings it up here. I don't know why he even, oh my gosh.
And here it is right here. It actually uses the equatorial rectangular coordinates. And there's other, here's just a YouTube video where you can calculate spherical coordinates back to Cartesian coordinates. You can literally bounce, and you should know this, McToon, and anybody who considers himself a math guy, this guy would vouch for it, that you can literally bounce between the perspectives. You just need the right mathematical formula. Not really my forte, but.
Like I said, Changing the coordinate system doesn't change the shape of the thing you're modeling.
There it is. This guy's doing it, and I've done it here. It does use indeed the Swiss ephemeris uses equatorial rectangular coordinates, which, if you think about it, really makes a lot of sense. Now, a great place to be considering buying Bitcoin, but what you have there's a square. I could display it with that, but really if you think about a rectangular coordinates, forget about the math formula that goes behind it. Think about it intellectually. This is your plane.
He's about to not think about it intellectually, by the way.
And that could be round, it could be a triangle down here. It doesn't really matter what the plane itself is, much like having mountains and things. But this is going to give you your location on any such thing, which is what this is. It's the cross right there, is the observer's location who's looking at the stars in his challenge. And the top of the rectangle is where the stars are actually located. It just makes perfect sense. But
if that was the case, the math would be based on it, which it is not.
So to me, that was interesting. Absolutely completed this challenge with his help. I don't expect...
For a globe. I helped him to do it on a globe.
Back to 10K. I expect people to be created this to try to look how intellectually superior I am. Look at all these. We've got 12 knots that we're at moving speed in the ocean there as he's taking this, which he even told me in the email. You had to butter him up a little bit, get him the inside, get some inside information so I can create the proper two-dimensional flat earth plane perspective of it. Buttered him up a little bit. He's a good guy. I like talking to him, but he was able to get enough information to where he actually confirmed that this was Arcturus right here. And so as soon as I just was able to locate Arcturus, I was just like, oh, okay, so I have confidence in this particular...
I'll show you how I did that. I sent him this with just Arcturus. Arcturus is right here. This over Africa, right? See that there on the right side? That's where Arcturus was at the moment that the sighting was taken. And then you can see around it, this circle here. This is the circle of equal altitude around Arcturus. So the observer is somewhere on this line. Right now, as you see, it intersects with the other two. But I sent him this screenshot of this with Arcturus there and without the other two circles, just so he saw how it's done on a globe. Literally sent him this screenshot, this one right here, without the other two stars. This is what I sent him, a globe. And I said 60 nautical miles per degree. That's how it's done. Right?
Particular calculation method, the Swiss ephemeris, which is given the correct star locations. Oh, and bingo bango, there's your location right there. Now, one thing that I was doing wrong is that I had the Barry center on, and just getting rid of that and just keeping a standard geocentric perspective, center of the universe. We get these. Geocentric
still is a globe.
Exact readout that you get when you apply all that other mathematical formula to make it spherical. It comes back the exact same, and that is quite literally the text that all the quotes of these past mathematicians and physicists on a much higher level than anyone I've had the pleasure of dealing with that have said, there's no way to tell whether the stars in the heavens rotate above us or we are in motion.
That's not true either. You're just quoting cherry-picked quotes out of context that were given to you by Witsit.
There's not, but most of them said through like a terrestrial experience. I disagree. I think the experiments you can do are pretty obvious, especially now with Zoom. They didn't have optical zooms back in the 1800s and previous to that. But just the flat Earth perspective of how your eyes work and what's happening with vision and lines of sight, you apply that with.
All right, so the Swiss ephemeris. Let me talk about that for a minute here. The Swiss ephemeris is the coordinate system, and the ephemeris. An ephemeris is it's typically tabular. It's tables and functions that describe positions of things in three-dimensional space. So the Swiss ephemeris specifically is an extension of an ephemeris that was created by NASA. I don't know why he's thinking that the Earth is flat and that he wants to use calculations by NASA. It makes no sense to me. But here is the header files. Was this from Manobratset? Was that you? Yeah, there it is. This is from Manobratset. Thank you very much for this. Look this up. Posted this screenshot. This is the in the header for the C class files for the Swiss ephemeris. So the Swiss ephemeris is based on NASA. It's where the locations of stars and planets, moons, asteroids are in the solar system, right? It actually models the Earth-Moon system as one system orbiting the sun. If you look at that, it's because of the Barry center of the Earth-Moon system. For us, makes a big deal on what we see. Anyway, so a unit, that's an astronomical unit in meters. That's the distance from the Earth to the sun. 150 million kilometers 93 million miles. You have the Hell grav const, that'd be the gravitational constant that's added in with a few other things. So you got G times the mass of the sun. That's what that is, right? And then geoconst, that's going to be G times the mass of the Earth. That's big G, right? And it even includes the units there, meter cubed per second squared. You've got Gaussian gravitational constant, sun radius, Earth oblateness. That's how much difference there is between the polar radius and the equatorial radius. Wisekoff, your model used all of these things. You absolute moron. You used the globe. You complete idiot. You're so dumb. You're so dumb. How can you think that you used flat Earth? That's all the globe. You moron. You absolute idiot. You used the globe. Now, I want to point out, and I mentioned this earlier, he can use star charts based on the globe. Why would you want to use star charts based on the globe? You're admitting the globe when you do that. It's a trap. I put that in as a trap, you idiot. Nathan Oakley, I put that in as a trap for you. I knew you wouldn't do it. You're just going to whine and not do anything because it's your grift. But Wisekoff, he didn't know I said it as a trap. If you use the celestial charts, even to do an attempt, you have just acknowledged the globe. That's what you did. You are free. Wisekoff, you are completely free to use the position of the stars in the celestial sphere, and you did that. But you are not free to use globe-based modeling. This all assumes that the Earth is a globe. And this is what you use. The Swiss ephemeris uses all of this. You acknowledged that the Earth is a globe. So all of the people saying that you successfully completed the challenge, all the other flat earthers are like, he did the challenge right. Yeah. You got the position using the globe. It's a trap. I trapped you, you bunch of idiots. Oh my gosh.
The rest of it, I mean, there's just so many strong inclinations, that we are flat and fixed. And not only that, but I also was able to call McTune out on his one of his best arguments, the theodolites. They're again imposing math. They're literally adding math to the calculations to make it work and to make it go over 180 degrees. But all those measurements are basically right bang on 180 degrees. But
so he's talking about these spherical excess measurements that I in a debate I did last week. Where you measure three angles. There's nothing imposed. You just measure three angles on a triangle, and they sum to more than 180. There's no imposing of anything. If they sum to more than 180, it's not on a plane. That's it.
Small margin of error. It's a few decimal. It's like a decimal point. But
yeah, and he's trying to hand wave away a 1 arc minute margin of error in measurements that are to 3 digits behind the decimal in arc seconds. He's 5 decimals away from the actual margin of error.
Anyway, so this was fun. I had fun doing this. I've completed this 10K challenge. It's effortlessly done. And from the flat Earth perspective, there's absolutely nothing globular, spherical going on here. This is
Of course there is. That's a projection of the globe, and all the calculations are based on the globe.
It's a flat two-dimensional perspective. It's just using the Swiss mathematical calculation, which is rectangular coordinate system. Again, some pretty nerdy math. It's literally above my head, but I'm just like a dumb monkey pressing buttons. I'm going to make it work. I'm a gamer, baby.
Yeah, you are a dumb monkey, and it's literally over your head.
Get to the final boss. I will get there, and I'm going to beat him. That's just how I get down. That's how I get busy, baby. But so this was fun. And yeah, this just goes through from the center of the Earth, the geometric center of the Earth. This is our center.
That's not the center of the Earth. It's the center of a sphere in the calculations.
fundamental plane in the planes of the Earth's equator. This is just our plane of existence. And so yeah, and when you use it rectangular, you can use degrees. This point of observation comes in, and you have your degrees that you're observing it. It all makes perfect sense. I couldn't reproduce it, without the help of my computer. I wouldn't have a choice or a chance. But just like the financial markets, and I've said this many times.
All right, so let's go back to the actual challenge. This is important. He says he could not reproduce it. He could not reproduce it. The exact method used to determine the position must be included in the submission. He doesn't know how it happened. All details used must be provided so a third party can perform the same steps to get the position. Now, certainly a third party could use that same application. It is an open source application, as far as I think so. And anybody could then go look, if it is open source, maybe it's not. Go and go look at the code to see if it is using the Swiss ephemeris, or if it's just pretending to use the Swiss ephemeris and is actually doing some flat earth math underneath. But unless somebody actually shows that it's not using the Swiss ephemeris, it's using the Swiss ephemeris, which is a solar system model, uses the globe. Anyway, this method will be tested independently of the answer to verify the same answer is obtained. The method must only use mathematics and data that presumes flat Earth. This does not presume flat Earth. This presumes that the Earth has a radius of 6,378 miles and is a sphere. So any methods presuming the Earth to be a globe derived from a globe invalidates the submission. Invalidated. So this includes maps, site reduction tables, dip charts, refraction tables, and calculations of distances over the surface of the Earth. Now, to really add into this, in order to draw those lines of equal altitude, he needed to use the distance of 60 nautical miles per degree. It's the only way to do it. At least the software did it that way. I have no idea if there's a different way to do it. Anyway, Wisekoff, if you're there, let me know. I will send me an email. I'll give you a Zoom link and you can come on and cry.
You don't need to know, what GAN was doing. You don't need to know what Ralph Nelson Elliott Wave was doing. We have computers that do that for us now. And so take that and use that as your advantage and be a pioneer in the markets and most certainly in the astronomy and just physics, life perspectives. Be that pioneer and build off of what people have brought before.
Be a pioneer by doing something you don't understand.
For us. But anyways, I don't mean to sound egotistical or arrogant or anything. I just had a lot of fun doing this. And he was a great guy walking me through everything, literally because he was interested in it as well. He's like, hey, he could see that there's something to it. And sure enough, this dumb monkey smashed the buttons and we got to the end game there. So yeah. I don't even know what else to say about that, but quite literally every piece of evidence that I've seen, this Earth is a flat fixed plane, and this makes sense of it astronomically on the exact same level of detail that we...
Quite literally, this used the globe confirms the globe. Can you be that dumb? How can you actually be that dumb and not need somebody to remind you to breathe? Why does he sound like a chipmunk? I have it playing at 2x speed.
We have now through our any other spherical coordinates. So just as he declines it, saying using other ones, this uses a globe. There's nothing about a globe. The only time it becomes a projection of the globe is when I make it spherical. This literally...
That's a projection from the globe. That's the AE map.
Starts out raw and nothing. I'll pull up the other one here. This is what you get. And you have to go in and set the time. You have to go in and set the calculation method. You have to pick which you want. Okay, you can literally just restrict everything. There's nothing. This is just a flat plane of nothingness. It's an open table. It's like a blank piece of paper. You have to create it. And it's not until you come in here and hit sphere that you make it a sphere, and it implies that spherical calculations. Until then, it's a flat fixed plane. There's nothing globular about it. And, this is not spherical at all. There's nothing that I can do to fix to make it a sphere. So it's absolutely 100% crush this challenge. Probably will never see my 10K for it. But anyways, this is my reply. Anyways, this is awkward.
Clearly you won't. You use the globe.
Doesn't use the globe anything until you choose to view it in spherical coordinates. It's just how basic the program is. It really is. You have to input everything. The Swiss ephemeris uses equatorial rectangular coordinates, which makes sense if you think about it. I just went through that. It does absolutely satisfy every aspect of the challenge, and you help me with the nerdy aspects of it, just making sure. And the crossing circles was the big thing. I didn't realize that the circle should cross. And if we look at his thing here, you can see that cross. It's in the exact same location. So really cool stuff. I didn't know that. And he kind of walked me through that, and I do appreciate it because it's helping me give a better understanding of astronomy in general. But
none of this is astronomy. This is celestial navigation. I mean, it touches on it a little bit, but I showed you how to do it on a globe. You did it on a globe, and then projected it on a flat map from the globe and said you did it on, you didn't. You didn't actually tell me the steps to do it. And so any flurf who's like, here, he won. The question to you is, what process did he use only using flat Earth to get the position? How did he do it? How did he get the position, the distance from the star GP to the observer? How did he get that? 60 nautical miles per degree. Well, I'm sorry, that's based on a globe. You need to provide the derivation of 60 nautical miles per degree. Now, I know Brian Leake tried. He tried it by going from 0 degrees north latitude, from the North Pole, 90 degrees north latitude, to 89 degrees north latitude. One degree, and and the angle changes it by 1, and it is almost 60 nautical miles. But of course, that doesn't work if you go between 90 degrees north and 45 degrees north. It's skewed. It's not the same number. And it doesn't work if you go between 45 degrees and 46 degrees. That doesn't work either. Your derivation is still based on a globe. Brian Leake. So, all right. And then this is his final one coming up. This is a short one. It shows, it really drills in, Wisekoff, how incredibly dumb you are.
You need to learn how to what is going on, sheeple? This one is just still version 2. Still follow-up for the haters that can't accept that L. You need to learn how to take an L in life. Makes you stronger. The best winners on this planet know exactly how to lose. And they make sure they don't lose.
Yep,
They
that's
do
what he
whatever it
did.
takes to win. The best winners that have ever been in existence know exactly how to lose. Now, I wish I would have kept all those links open, but the NASA links, the Swiss Ephemeris links, they're basically all just duplicates from astro.com and astrodentist. None of them actually claim heliocentrism at all. They actually...
I don't know how you could think that. It literally does right there. It has the distance to the sun. The distance to the sun is 150 million kilometers. How do you not know that? How is that confusing to you? All right, I'm going to send him a link.
reference geocentrism if you read them, which none of you probably did. You just immediately saw that it said NASA, and it was a calculation, so you assumed, I would imagine. But you should try to look into that. Not a problem, though. Not a problem. As other people have said, you are using heliocentric. I'm not. You have to click this button to make that heliocentric. But no worries. I won't use any calculation method, even though the ones that I'm using were fine. It doesn't matter. But everything in the first video is completely valid. But no worries. No worries. We'll go with nothing at all. This is truly using the stars to navigate. And look at this is going to hurt a little bit. We're just going to put on the descendant and the eighth cusp. Oh, God, dead center. No, it's not quite as easy to do, to navigate. It's an extra variable, unlike the other one. You know, and I've seen other ones where they actually triangulate. There's a little triangle that we created. This is just basically dead center of the cross points, as opposed to, the first video where it's just dead center of where the cross is. That's the calculation.
That's a pretty sloppy position.
Imposing that calculation gives you the additional, accuracy. But there it is, with zero calculations.
There are calculations there. How did this program do anything? It calculated things. It used the Swiss ephemeris. It used the distance of it used the radius of the globe. It used, it's tons of calculations. Thousands of lines of calculations.
Awareness of where the stars are, their geographic positioning. So that's tough. So now this is two different versions of completing a challenge. What's your excuse now? Fuck you. Pay me.
No. You used the globe, you absolute moron. All right, I sent him the link to the Zoom link. I don't know, Phil. I mean, he should absolutely be hanging his head in shame because that was embarrassing. So there it is. If anybody thinks that he did it, you go ahead. You write out in your own words how he did it, because the challenge, remember, is to tell me the process, not just to answer the question, but it's the process that I want, because here is the process for doing it on the globe, right? This details the process, right? It's involved, right? There's a lot going on in doing it, and underlying it is a ton more stuff, right? Of course, flirts are like, you're presupposing the globe. Of course we are. You come into this saying, yep, the Earth is a globe, and everything we do is based off of the globe. In here. Everything. It's all based on the globe. right? And it works. So if you presuppose a globe and it works, guess what? Your presupposition has an awful lot of merit. All right, Dave Kirshner has a super sticker that says wrecked. Yes, it does. Yes, he was. Well, all right, I'm talk to the chat a little bit. I kind of just did that whole presentation there without talking to the chat. So thank you very much for following along, and I'll see what you have to do. See what you have to say in the chat there. Let's see here. All right. Pulling up some stuff. Good to see you all here. How many? We got 500 people. Wow. That's a lot. A lot of people just enjoying watching a flurf just make a fool of himself, I guess. So I appreciate that. So we've got Mr. QTube, first name Fa, says, how'd the debate go? I had to use my phone for phone type stuff, so I missed all but when he first got on. So the first debate was with Adam King, who had done apparently no research at all, even though he's been a flare for 5 years. He's like, the horizon always rises to eye level. I showed him, I applied his math. I applied Flurf math. This is actually what Flurfs claim when they say that the horizon should rise to eye level, because this so far away that even at high elevations, the angular dip is very, very small. And he didn't understand. I'm like, just draw a picture. We couldn't draw a picture of it, of course. And then when I kept just hitting him with stuff, he ran to his Bible. And I'm a Christian. Lots of Christians around here. And for the most part, they think the earth is spherical. Anyway, so yeah, when he does that, when somebody does that, then I know they're getting into crazy. They're going to get into a little crazy stuff. And he had already gotten into some stuff that was pretty rude, off topic. So I'm like, you're not going to, this isn't your platform to talk about this other stuff. So, Scorpio Nick, didn't he admit he couldn't do it without a computer? So how was celestial navigation done centuries ago? Well, of course, yeah. He did not know what he did or how he did it, or could not explain how it was done other than click, click, click. That's what he knew. So, Aaron Finley says, free member chat, Lake Titicaca. That is all. Thank you for that. Hugh Janus says, for $5, lovely Lake Arapa is just 5 miles northwest of that hipster haunt Titicaca, but with equally exquisite views. I really want to go. I mean, I have to go now to Lake Titicaca, don't I? I have to do some celestial navigation on site. So, Stringer News 1 says Wisekoff is a dumb cough. I don't have an argument to that, Stringer News 1. Could not disagree. We've got Matthew Rain 1 says his smugness gives me heartburn. Yes, there was an awful lot of smugness. And if you watch his other videos, there's an awful lot of smugness in there. I mean, he's not Witsit smug, right? The Witsit's ego has no Carmen line. Think about that one. Mr. QTube, first name Fast, says, I'm a flat tuner. I believe MC Tune Live is flat. I've been seeing that more lately. People like, all maps are flat. All pictures of my dog are flat. So what? P-Barn says, as an Aussie, the level of offense is equivalent to a slap in the face with a wet lettuce. Yes, the azimuthal equidistant projection greatly distorts Australia. It distorts South America and Africa as well, but it's not as apparent because there's more of them, and so it's kind of apparent when you look at South America, and if you look at it from a little better view, Australia or Africa just looks chubby. It's really, it's got it's a wide bottom girl, but but they make the rock world go round, so that's okay. It's not quite. I know. Sorry. Don't. It's not quite the lyric. I know. Many Karen. Speaking of wide bottom girls, Flurfs have come up with a model, and rumor has it she's a real woman, not blow up or anything. True, but apparently she's got a wide bottom. William Foley says, for $5, if you love polar coordinates, you must have loved your AC Power EE classes. Yeah. I don't remember much of them. I have to be honest. The AC, the three-phase stuff, that was not something. Saying I loved them would not be the right series of words to describe. Yeah, three-phase stuff was that was. It's like, yeah, I'm glad that's done. Let me sell the book. Definitely so. It's and some books you keep because you like the class, right? If you like the class, you keep the book. That's what I did. That's why I still have my Pascal book. I loved Pascal. Some books you kept because they would not buy them back. And some books, and then there's a range in the middle. So anyway, Beaver Zero. Speaking of, Beaver Zero's Brainy Beaver, who is the escrow holder, says, I blame how smart you are for me dropping Brainy. Brainy Beaver, you are brainy as well. You don't sell yourself short. Now just remember, I have sent off the Zoom link to Wisekoff, who has as yet not accepted and is not here. That's fine. You're not necessary. Ableist says, brilliant, Michael. Well, thank you very much. I did enjoy it ever so much. It's a trap. It is. Because if the earth were flat, you could do all this. You just do it, people. You just go do it. I did this challenge for $100 and I had like 15 entries in an hour. And they were all right. With, you know, they're coming somewhere a little farther out, but flat earthers, how stupid are you? We could do it on a globe. You can't do it on flat earth. All these flat earthers have said it's possible, but none of them have done it. You dummies. Mutaki says, some books I kept because I hated the class. What? Sleet says, a class so bad the textbook has no market value. Love it. Matt Klein says, I hold a high voltage electrical card from my days in the coal mine. I had to take a hard class on AC and DC theory. Wow. That's something. That's cool. Many Karens says, truly, you are Mike McToon of the clan McToon, and there can be only one. Thank you for that. Thank you for that. So, I don't know. Where are you, Wisekoff? What happened? I don't know where you live in Canada, but I know it sometimes it's cold in Canada. Maybe it's affected your feet. Are your feet cold? Could be. Dave Pierce says, Brainy already blew that Bitcoin on maple syrup and a Mountie outfit. It rains maple syrup in Canada. What are you talking about? That's free. Just put out a bucket and you'll have some in the morning. So, Brimstone literally just tuned in. Welcome. You missed the destruction of Flat Earth by a Flat Earther. Again. So, I don't know. We've got, thanks, Bob. We've got interesting. We've got spectroscopy requires a container. And we've got Wisekoff using a globe to do celestial navigation for Flat Earth. I don't know. Is that guy suggesting we need to decapitate? Oh, no, Minnie Karen. So it's free. So it's a Highlander reference from the movie Highlander, starring some guy and Sean Connery. So Sean Connery is the man, even though he's only the second best Bond. First best, everybody. It's in the chat. Who is the first? You know who the first best is. Mr. United for the Children. Yes, it is that guy. I don't care. Who cares? It's Sean Connery. Who is the best James Bond? Somebody, Stringer News 1 said Roger Moore. But there you go. Oh my gosh. Reposidan says Pierce Brosnan. Indeed, Pierce is the best. But my favorite, this is weird, my favorite James Bond movie. What's my favorite James Bond movie? I've said it before. So if you know it, if you know my favorite James Bond movie, that will be Tom Cruise is not James Bond. Snipey McSendit. Goldfinger is not. It's not Moonraker. It's not Octopussy. It's not Casino Royale. It's come on. There it is. Hold on. Molossus on Her Majesty's Secret Service, which isn't even the case anymore because it's now His Majesty. I don't know. All right. Well, Brimstone did a super chat for $5 with no message. Thank you for that. So, it seems his feet have gotten ice cold. Wisekoff has not shown up. I would like to thank you, Wisekoff, for once again, like everybody else, like all other flurfs, you have proved the globe. Dave Cernak says that Wisekoff is locked up in Mallory's basement. A fitting demise for Wisekoff. Mallory, treat him with all the appropriateness that I know you can. So he will, yes, he certainly will have a video tomorrow. I got some people saying that there's buffering. I don't know. I'm not seeing any on my side. I'm still sending out at 6,000 kilobits per second. So, all right. Well, I'm going to shut it down. Thank you very much to everybody. Thank you for coming, for joining the 490 people of you here. I each and every one of you, I love you deeply. Of course, you know that's not the case, but I appreciate that you're here. Maybe we could have a James Bond talk-a-thon at some time in the future. Anyway, maybe later this week, maybe I'll have another live stream. We'll see. We'll see if it happens. I might be able to make it happen. But until then, you don't have to go home, but you can't stay here.